Welcome to the next problem. So this is a previous year problem, 2020 December problem, asked for 4 marks. Okay, this is a direct problem. If you know that relation, you can directly answer the problem. But it's a very small derivation, so we'll do that derivation and finish it. So basically, they are asking this is circular wooden log. From this, you have to cut and make rectangular beams. Okay, this diameter is given as 400 mm. Okay, so they're asking what is the strongest section in bending. For bending, what is the strongest section that you can make? For example, so this is one way of making it. So if I cut like this, if I remove this, I'll get a rectangular beam. Okay, so another way of doing it is I can do like this also. So assume to be straight line, so I can remove this. This is another beam. So there are many different types of beams. I can different dimensions of beam I can get. They're asking which dimension will give you or what will give you the maximum bending strength. Now, what is bending strength? You know that bending equation m by I is equal to sigma upon y. Okay. Now, what is the meaning of this? If you have a rectangular beam, so we have neutral axis at the center. Neutral axis. This will become tension here in the bottom. If you're sagging, if it is sagging, there will be tension here in the bottom. There will be compression in the top. Compression in the top. And the distance in this equation, it is nothing but y is the distance from the neutral axis. This is y. Okay. So for example, if you want to find stress at this point, you substitute this y distance in this equation. The moment and I will be given at a section. So in this section, the moment and I will be m and I. It is constant. Okay. Now the strength of the section depends upon the material strength. So let's say this is wood. So maximum compressive sigma C and sigma tension. This will be constant for this material. Okay. Whatever be the dimension of the beam, the stress at which it fails in compression and stress at which it fails for tension, it will be constant. This may be different value, this may be same value. But depending upon the value, we have a moment at which we have this much strength. Okay. So we can say m equal to sigma into I by y. Okay. So what is the maximum value of stress sigma C or sigma T? It is nothing but when y equal to the depth by 2. Y equal to depth by 2. So this is D, this is B. Okay. So that means m equal to sigma into I upon D by 2. This is the when y equal to D by 2, we have the maximum stress. Okay. So this stress will be sigma m. Will be the maximum stress. So for a rectangle, I is nothing but sigma n into BD cube by 12. BD cube by 12. So 1 by D is nothing but 2 by D. So this is nothing but sigma m into BD square by 6. So this is nothing but section modulus. This term is what is known as Z section modulus. Section modulus is nothing but I upon y max, maximum value of y. Okay. So moment depends upon moment capacity depends upon. So sigma m for the material, it is constant. So if it is wood, let's say teak wood, it may be some value about 20 MPa, 10-15 MPa. If it is some sal wood, it may be some other value. So but depends upon material, it will be this will be constant. Okay. Now BD, this is different. So maximum value of moment capacity, this value can be maximized by maximizing this value. Okay. So that means we want to find a relation between how can we optimize this, or which value of B and D will give me maximum value. Now, what is the relation between B, D and the diameter of the bar, diameter of the log? So you can see that this is nothing but D. This is nothing but B. So this is capital D. I'm sorry. This is capital D. This is capital D. This is B. So if you observe, I can draw a diagonal here. Okay, this diagonal is nothing but the diameter of the bar. Okay, so in this triangle I can apply Pythagoras theorem. So when I apply Pythagoras theorem, I can b square plus d square equal to small d square. Okay, so that means capital D square is equal to small d square minus b square. So this I can substitute here. This I can substitute here. So I'll do that. I'll substitute it here. I'll get m equal to sigma m into b into what is d square? It is nothing but small d square minus b square upon 6. Okay. Now if you observe this, for a given material, sigma m is constant, 6 is constant. The diameter is also constant because the diameter of the log is fixed, 400 mm. So maximum value of moment capacity we can differentiate with respect to b. So this is b sigma m upon 6 into d upon db of this is bd square minus b cube. Okay, so this we have to equate to 0 by maximizing the moment capacity. So this is nothing but this will become 0. So this terms is not relevant. Differential of bd square is d square minus 3b square equal to 0. Okay, so this gives me d square equal to 3b square, or I can say b equal to d square upon 3, b square is equal to d square upon 3, or b equal to d upon root 3. This is the relationship between b and d for b for width of the section for the maximum moment capacity. Okay, so that means in our case, so this answer, this you can directly answer if you remember this relation. If you remember this equation, you can directly answer this problem also. Okay, so we know that small d is 400 mm. So width of the section, width of beam equal to 400 upon root 3. What is the value? This comes out to be 400 upon root 3, 230.94. So 230.94. So let's say 231 mm. Okay. Also, we know the relation here. D square is equal to small d square minus b square. So depth of the section is small d square minus b square. This is nothing but d is nothing but under root of 400 square minus 231 square. So this is what? Root of 400 square minus 231 square. So this is 326.55. 326.55. So say 327 mm. So the dimension of the largest rectangular beam is nothing but depth is 327 mm, not largest, the beam with the maximum moment capacity. Width is 231. Okay, so this is the beam which you can come out of the, which you can cut out of the given log. So I hope this is clear. The most important thing is how do you find this relation? I hope this is clear. M is nothing but sigma into I by y. The maximum value of sigma is nothing but it is constant for a material. So that is the concept, basic concept. The bending strength of the material is the maximum bending stress it can take. Okay, so it can be in tension or compression. It is fixed for that value. So maximum bending stress occurs when d equal to y equal to d by 2. So we substituted that and found a relationship and use that relationship. So this is how we solve this problem. Okay, this is only for 4 marks. So we don't have to write all these things. If you remember this relation, that is width of the largest width can be diameter upon root 3. If you remember, you can remember this and this, you can directly solve this. So this result, if you remember, you can solve this in 5 minutes. Then also you will get the answer, get the full marks. Okay. So I hope that's clear. We will solve another problem in the next video.